All right. We're starting our new unit on vectors, but today we're just going to be reviewing. We do need a little bit of trig in this topic. So today we're just going to be reviewing. So this is everything today you've seen from first semester. We're just going to practice SOHCAHTOA and some of the things that we need for this unit. So we're not going to really hit the new material until Monday. If you guys can turn to the very back of your packet, I put the calendar and the and also a summary sheet at the back page, just so that if you want to just keep it in the packet, you can, or if you want to tear it off and just have it, because before I would give you a separate sheet for the calendar, but I figure, well, if I just put it at the back, then you guys can decide whether you want to just keep it in the packet or whether you want to have it as a separate sheet. If so, you can just tear it off yourself. Okay, so today we're just doing right triangle trig review. Next week we're really going to start vectors. I think you're going to find this unit it's not too bad until really when we get to word problems, but we're just kind of building our knowledge piece by piece. So I don't think you'll find this to be too difficult. No quiz next week. We do have a quiz the following week, Wednesday, and then we're going to go into applications, word problems, and then the following Thursday, vectors unit test. Okay. Okay, so today probably won't be a very long lesson here. We're just going to work through the first 2 pages. Okay. Okay. If you guys can have your calculator out, I think that would be helpful as well. Okay, starting with number 1, find the length of the hypotenuse and the angle of elevation. So anytime we want to find the angle, we're just going to be relying on tangent, because tangent is really going to kind of give us that slope relationship there. So we'll be using Pythagorean theorem to find the length, and then we'll use tangent to help us find the angle of elevation. Okay. All right, so Pythagorean theorem, a squared plus b squared will give us that hypotenuse for a right triangle. Add that up, take the square root. Okay, questions there? If you want to find the measure or the angle of elevation for theta, we just basically it's just going to be involving rise over run. So we're always going to be involving tangent to figure out the measure of this angle. Okay. And also right now it's tangent because those are what's given to us. We have our leg values given to us, so that's why we're going to be relying on tangent here. Okay, so tangent of theta equals opposite over adjacent. Okay, we want to solve for theta, so we want to move this tangent over. We don't divide tangent, we do inverse tangent. Make sure that you are in degree mode. Okay, you're in degree mode here. Okay, so if I want to find inverse tangent, I just have to write this out. Inverse tangent of 7 over 24. Make sure that you are in degree mode. You can hit tangent twice to get to inverse tangent. 7/24. 16.26 degrees. Oh, let's see. Yeah, I think, yeah, for now, let's go to the 100th. 2 decimal places. All right, pretty straightforward. Go ahead and try 2 and 3, and then I'll work through at the same time that you guys are trying them. Okay. Actually, you know what? We could use any of the sine, cosine, or tangent because we have all 3 sides, right? So if you want to use sine or cosine, once you find your C value, you can use any of them. So we're not just restricted to tangent. I just said tangent because the givens are the x's, the opposites, and adjacents. But you could use any sine, cosine, or tangent and still get the same thing if you have all 3 sides. Okay, good so far. Okay, any questions so far? All right, when you get to 4 through 6, you're going to have a variety of ways to work through these, and just kind of give you some refresher here in terms of how we can approach it. It says find the length of 2 legs for the given triangle. Let's say I want to start with x first. Okay, so if I want to solve for x, I have to use the value that I don't want to involve both variables because then that's too much unknown. So let's say I just want to target x. If I want to target x, I want to use 38 degrees and 28. Which trig function will allow me to hit x and 28 if, from the perspective of 38 degrees? Cosine. All right, so if I can do cosine, all right, cosine of theta is equal to adjacent over hypotenuse. oops, over hypotenuse. All right, we set everything up here. Cosine of 38. If you want to put it over 1, just so that you know that there's some cross multiplying that has to occur here. X times 1 equals 28 cosine 38. This is not degrees, right? This is going to be miles. All right. Any questions with X? All right. How can I solve for Y?
Or just use sine.
Yeah, you can use sine. Yeah, you can use sine. Let's practice using sine. But yeah, Pythagorean theorem also works. If you have 2 sides of a right triangle, you can always find that missing side. But let's just get some more practice with trig. So let's practice using sine. So if I want to get to Y, sine of 38 equals opposite over hypotenuse. Yeah, so for 5 and 6, if you guys can practice using sine and cosine, it's not wrong going through Pythagorean theorem once you get that 3rd side, but just so we can refresh our memory. Okay, cross multiply, y equals. All right, any questions with 4? All right, practice 5 and 6, and I'll work through the problems the same time that you guys work through them. My bad. Sorry, guys, I copied the wrong number here. Cosine of 21. Okay, any questions? All right, number 9. Sketch each angle in standard position and then state the quadrant where each angle has its terminal side. Okay, this should be pretty easy. We know that along the coordinate plane, right, 0 to 90 degrees is going to be the first quadrant, 90 to 180 degrees in the second quadrant, 180 to 270 is the third quadrant, and 270 to 360 in the fourth quadrant. Okay, 140, we know that's going to be in the second quadrant. And we just indicate where that angle is, starting at our initial side, going to the terminal side. That's our theta there. $285, where is that? Which quadrant will that be in? Fourth, yeah. 270 is here, so 285 is slightly in that fourth quadrant there, so. Okay, terminal side passes through -6, -5. Where is that going to be? Which quadrant? Quadrant 3, yeah. Okay, we're just going to finish up this page, 12 through 14. All right, the difference with number 12 is that we're going to be going clockwise, right? Not counterclockwise, because we're going from 0 and we're headed towards -70 in the fourth quadrant. All right, 220, which quadrant? Third. All right, terminal side passes through -1216. Which quadrant? Second, right? Okay, just left -12, up 16. think I just really want to make that as a dotted line just to indicate where that point is. Okay, page 3 when you're ready. Okay, does anybody still need page 2? Everybody good? All right, page 3. Okay, sketch each angle described in standard position where theta is between 0 and 360 degrees. Find the distance the point is from the origin and the measure of the angle.
Yes, sir.
Okay, so the terminal side passes through 2, 9. Let's go ahead and give a visual as to where that could be. First quadrant. Okay, so 2, 9. Find the distance, the point from the origin. So distance is really just the hypotenuse here. And then measure of the angle. Anytime we're given ordered pairs, that's an x and y value. We're really going to rely on tangent again. Okay, so Pythagorean theorem, just like how we did on the first page, and then you'll use tangent to find the measure of that angle. Okay, first quadrant. There will be some adjustment we have to make if it's a second, third, or fourth quadrant, but we start easy with easier ones here. First quadrant. All right, so to find the measure of angle theta, we'll use tangent theta. Y over x, opposite over adjacent. (77.47 degrees). Okay, the thing to keep in mind is that the theta that you're going to get in return is going to be a reference angle. Okay, first quadrant is not going to be a big deal because your reference angle is always it's going to be between 0 and 90, which is where it's located as well. But when we get to something where the theta is landing in the second, third, or fourth quadrant, we need to add or subtract from 180 or 360. All right, so you have to make that adjustment. But right now, first quadrant, we're really not going to see any big distinction here. Okay, let's try number 16. Terminal side passes through -8, 6. Okay, which quadrant is that in? Second. Okay, keep that in mind there. Oh, my bad. That is the theta we're going to find, but we're going to have to find the big theta, which is counting from the terminal side from 0 degrees. Okay, but for now, I'll put theta. Maybe, okay, I think a notation that could be used here is using that theta prime, which is, it's a theta for our triangle, but it's not the big theta overall. Theta is going to be counting from the origin. So I'm just going to use that theta prime to indicate that we're kind of solving a starting problem here, but then our big theta, we have to count that full angle measure from 0. But let's figure out this piece first. Okay, Pythagorean theorem, get to that distance pretty easily. Okay, again, we'll rely on tangent. I'll use tangent of theta prime is equal to 6 over -8. So we get -36.87 degrees. That just tells us that we are having to subtract from 180 to get to this angle measure, right? We want to remember, these are just reference angles here. We always are going to have to add or subtract from 180 or 360 if we're trying to deal with the second quadrant, right? So here, what's 180 minus 36? So you guys get 143. Okay. Okay, so that's a big thing I want you guys to keep in mind, that if something is not in the first quadrant, you got to involve adding or subtracting from 180 usually, and then if there's a fourth quadrant, you may have to subtract from 360. Okay, terminal side passing through -10, -10, third quadrant. -10, -10. I'll call this theta prime because it's not the true big theta that we need, but it is helpful to kind of get that angle of the triangle first. Okay, Pythagorean theorem. So 45 degrees is a measure of this angle, but we know it's going to be in the third quadrant. So we need to be able to provide a theta value that is in the third quadrant. So how do we get there? Yep, add what?
45.
Yeah, add 45 to 180. So keep reminding yourself, right? Okay, which quadrant am I supposed to be in? And make sure that your theta value is matching where it's supposed to be, right? Okay, try number 18. If you can get number 18, you should feel pretty confident that you remember the big ideas from that we need to carry through into this unit. All right, everybody good so far? Getting to that negative 59.42 degrees. That's my theta prime, but how do I use this to help me get to a theta that should be in the fourth quadrant? Right, we're looking for a theta value between 0 and 360. So this is going to be the reference angle that's going to help us get there, right? So 360 minus 59. All right, questions here? All right, 4 more below here. Sketch each point described with its given distance from the origin, an angle measure and standard position determine the order pair coordinates described. So we're going to plot everything, put everything down, and we should be able to rely on sine and cosine to help us get to the x and y values. Okay, so the point lies 15 inches from the origin. All these are going to be hypotenuse values. Okay, hypotenuse of right triangles here. Hypotenuse given. Okay, so 320 degrees. That means we're counting all the way to the fourth quadrant. But we're trying to create a triangle. Remember, any triangle that you're building, whichever quadrant you're in, you always make sure that you build your triangle with which axis? X or the y axis? Always X, yeah. You always have to involve the X. Never build your triangle involving y axis, then it's going to be off. So it's in the fourth quadrant, we're going to involve the X axis. There's my theta. Oh, but actually we need to fill that value in. We can figure out what that value is. Okay, so if we're all the way over at 320 degrees, and then you know you're ending at 360, what's this angle measure here? 40. Okay, so that's the reference angle that we're going to be using to help us find ordered pairs. Okay, we know the hypotenuse is 15. So now our job is just to figure out x and y. When we find x and y, we're able to find the ordered pair, which is right here. We're trying to figure out what this ordered pair is. So to find x, we can use cosine. To find y, we can use sine. Cosine of theta is equal to x over 15. My theta is 40, so cosine of 40 is equal to x over 15. You see a similar formula above. The y and the x, the r just means radius, but it's the same thing as opposite over hypotenuse and adjacent over hypotenuse. Cross multiply. Yeah, let's go to the 100th place again. So 2 decimal places. It says determine the order pair. So just take your x and y and put it in order pair form. But we need to make sure that our order pair is consistent with the fourth quadrant. Fourth quadrant has what? Positive x and what? Negative y. So we got to make an adjustment. We got to make an adjustment to put that order pair in the appropriate quadrant. So that y value needs to be adjusted. So even though we're getting all these positive values, we need to kind of adjust on our own what the positive and negative values are. Right, I need to go 11 units over and 9 units down, so positive 11, negative 9. Okay, any questions with 19? Okay, so you're going to follow that pattern for the remaining 3 problems. Okay, so go ahead and try that. I will show my work after you guys had a chance to try it. So try number 20. Mm-hmm. Okay, see how your setup looks. Okay, that's what I got for my x and y value. Do we need to make any adjustment if we want to put it in order pair form? Yeah, third quadrant, right? To get to my third quadrant, I got to go left and down, right? So negative x and negative y. So I need to make that adjustment based off of which quadrant we're in, right? All right, two more. Okay, so those are my x and y values, but we're in quadrant 2, so what's our order pair? Thanks.
Negative x.
Okay, do we need to make any adjustments here? Are both these x and y values be positive? Yeah, negative x, positive y, right? Second quadrant, go left, that's negative, and up, positive. All right, try 22. All right, 22 is easier, right? First quadrant. Okay, first quadrant. So, okay, got it. 25.22. Yeah. Mhm. Hopefully you guys feel comfortable with all these review here. We'll be building on this in our upcoming lessons. All right, if you guys can finish up, and I will come around and check off pages 2 and 3.